Osmosis, simply defined, is diffusion of water. Okay? So from a high concentration of water to a low concentration of water. Okay? Another way to look at it, because there's two different ways to look at it, and usually one way works better for some people than others. The other way to look at it is water flows from a high concentration, from where there's a low concentration of particles to where there's a high concentration of particles. An example of that you might have seen of this is, like, have you ever, like, either yourself or one of your roommates or family members, like, left some food on a plate, left it in the sink, and then left, like, the food gets waterlogged, you know? Mm-hmm. So you get like a pepper, okay, the pepper's sitting there. When it sits in the water for a really long time, what happens to it?
It starts to like get gross and dissolve.
That too, but it also swells. Haven't you seen it like get a little bigger?
Yeah.
You know, it's like looks a little fatter. You're like, well, that food looks fat and ugly. But yeah, it does start to dissolve too. That too. So I'm gonna just draw a jar instead. So here's your sink. Here was the little pepper that was sitting here, right? It's in a bunch of water. We're just gonna have a high concentration of particles, like sodium and stuff like that. Where is it gonna be? In the water or in the...
It's gonna be in the pepper.
Yeah, the pepper has a lot of, there's a lot of things that make it up. So it has a lot of different particles inside of here. So the water flows from where there's, there's probably some salt and stuff from the stuff washed off the plate. And it could even be a higher number, but they're a lot more spread out, So the water flows to where there's a high concentration of non-water particles. Or it flows down its concentration gradient from where it's a high concentration to where it's a low concentration. Two ways of thinking about it.
Okay.
Yeah. So it flows in, and that's why it expands. Because the water flows to where there were more particles, non-water particles. Okay? So, really important when we talk about this cell. Because we talk about red blood cells a lot. So, if I put a red blood cell in straight water, what would happen?
It would start to get bigger.
Start to get bigger.
The water.
Because there's more particles in here than are in the water. Okay, so it starts to flow in there. Okay, what if I put the cell in salt water, like from the ocean?
It would disperse more stuff because it's trying to
What do you mean disperse more? Because I think you have the right idea. I'm not sure.
Like the particles would go out because it's trying to balance it.
So real quick, there's one thing that I didn't say in osmosis. Osmosis, what time is it? Are we time?
Yes, 3:15, so
Okay.
a minute away.
Okay, cool.
Thank you.
Cool, we'll wrap up soon. Okay, there needs to be a semi-permeable membrane. Means some stuff can go through, some stuff can't go through. Semi-permeable.
Okay.
Okay? So water can go through, but the other particles can't.
Okay.
Okay? So in this semi-permeable membrane, the water can flow in or out, but the particles can't flow out.
Okay.
So the particles stay in here. But so if this was salt water, so there's a ton of particles all around, so just lots of other particles, the water in the cell is going to flow out. The little water that's in there flows out.
Why is that? Sorry.
It's the principle of diffusion that I talked about, or osmosis, where water is going to flow from a low concentration to high concentration of particles. Like I can get into some nitty gritties, I'm just trying to figure out how much you want to know. Because if there's a lot of particles out here, there's more particles out here than there are in here, concentration-wise. So the water would flow down its concentration gradient.
Okay, that makes
Okay.
sense.
Because cells are 0.9% sodium NaCl solutions.
Okay.
That's the concentration in a cell. So if I put it in a 5% NaCl solution of water, then the water flows out.
Okay, that makes sense.
Whereas if I put it in pure water, then the water would flow in. That's going to be the picture right here. That's tonicity. We always use tonicity in comparison to a cell. So a hypertonic solution, hyper meaning it has more particles, so more particles would flow out, would be like the 5%. Hypo would be if it was like pure distilled water, 0%.
Okay.
Isotonic would be 0.9%. So it's the exact same.
Okay.
Okay?